All right, so let's start with introduction to cloud computing. I mean, cloud computing is like a huge topic in itself, but we will try to go as deep and as wide as possible in this 2 hours, within 2 hours, right? So just a very brief introduction. My name is Sarat Fakhri, and I have been involved in data science for a very long time, as well as blockchain, as well as cloud computing. Okay, so so let's first start with what this course is all about. Okay. First of all, this is a beginner level course, all right? And secondly, it aims to equip you with an understanding of what cloud computing is. And the purpose is that once you know what cloud computing is, you'll be able to know like which areas to go deeper into, or it will help you make better decisions about cloud computing. And by the end of this course, you should be able to understand what is cloud computing, grasp the depth of cloud computing in detail, and comprehend the relationship between cloud computing, big data, and data science, because all these are interrelated terms, and you will know like how they are related to each other. And also identify different aspects of cloud computing, know what skills are necessary to tackle cloud computing. So if you want to specialize, then which skill tree do you want to go with? And have a general idea on the tools necessary to work on cloud computing. And acquire a general overview on the tools necessary to perform various tasks pertaining to cloud computing service providers. So you know that different service providers have slightly different specification. So you need to know all those things. And awareness of the careers presented by cloud computing and its associated technologies. All right. And get a bird's eye view of the cloud computing. So it's more like a breadth view, like a broad idea about what cloud computing is. And be able to grasp the resources required to undertake. Uh, I can hear some background noise. Maybe somebody's mic was on. Anyway.
Yes, already mute.
All right, great. All right. So you'll be able to grasp the resources required to undertake an endeavor into cloud computing. All right. So this is what this course is, but let us also understand what this course is not, so that you have the right expectations from it. Okay. So this is not a programming course. I mean, we won't go into like coding and hands-on approach with this. So although we may discuss various programming disciplines, but only to the extent that you will know what it is for. Okay. The second thing is that we should not be learning AWS or Azure, right? Despite being synonymous with cloud computing, both AWS, Azure, and all other like Google platform as well, we will know what they are and what they offer, but we will not go into details of it. So it is definitely not a hands-on approach. And we shall not be delving deep into any particular aspect of cloud computing. Right? I'll tell you in general what different aspects are, but we won't be going into full detail of those different aspects. And there shall be no case studies as well. Okay. and this part should be obvious that it won't make you an engineer or expert in any way, but it will give you a good idea where to go from here. So some guidelines are that every definition that we tackle will evolve as we progress through the course. So what happens is that whenever you have a complex thing, so you won't be able to fathom it all at once. So I will give you bits and pieces first. So I'll make like the first pass at the definition, then I will explain to you from a different angle, right? So that you have a full 360-degree view of the topic at hand. All right. And we shall take a very layman approach to comprehending very complex topics and grow our sense of understanding as we move forward. And this course will not make you an expert, and this course will help you if you uh, decide whether you want to delve into the world of cloud computing and to know what career paths are there in the field of cloud computing, and to make informed decisions on what skills to adopt and train in if you do choose to follow a certain path pertaining to cloud computing. And especially people who are managers, who are managing their people, they will be able to decide that, okay, so our organization has these kind of needs. So we can send our personnel to this aspect of cloud computing, okay? And to be able to understand what sort of team you would need to have a cloud computing department, right? So let's go with the most fundamental definition of cloud computing, that cloud computing is the on-demand availability of computer system resources, especially data storage and computing power, without direct active management by the user. Large clouds often have functions distributed over multiple locations. Each location is being a data center. So let's deconstruct this Wikipedia definition, what it is. Okay, so cloud computing is the on-demand availability of computer system resources, which means that on-demand means when you demand a resource and maybe your needs go up, you need more. So you can avail more of the computing power, okay, on demand. All right, so it's not fixed. So especially data storage and computing power. So remember that some of the applications that you do, they are they can be data intensive or computing intensive, right? So data intensive things are like, data from cameras, traffic cameras, like they're very data intensive. They require lots and lots of storage capacity, right? But things like machine learning, right? They are computing intensive. So you will be able, according to your need, you should be able to avail of these facilities on demand. All right, so that's one of the aspects of cloud computing. And without direct active management by the user. When you're availing the cloud, you don't have to be expert in managing it. You just have to only understand what your cloud provider provides you. Okay? So large clouds often have functions distributed over multiple locations, each location being a data center. Again, this is how the cloud computing is implemented. And as far as you're concerned, you actually don't care, right? How they're storing your data and how many places. That's taken care of by the cloud provider. Okay. So now let us have a look at the demand for cloud computing. Why do we even need it? All right. So let's start with a little bit of guesstimation here. Like, how many computers do you own? Right. I personally own, I think, four computers. All right. And you see, yeah, so Nurul owns two computers. Right? But remember that even your mobile phone is also a computer. So, but if I count mobile phone as well, then I own six computers. All right. So anything that has computing power, that is a computer, basically. So let's say that you like taking photos. Okay, yeah, so Nurul has four of them. Let's say that you like taking photos, selfies, all right? On average, your photos are about 24 MB, okay? And so 5 images daily in a year, you'd have like, if you calculate, it will be 45 GB, right? I mean, I don't take 5 photos every day, but I'm sure there are some people who take at least 5 photos every day, all right? So if you take 5 photos every day for 1 year, you will have to have a space of 45 GB, okay? Let's say your phone has 256 GB of space. Your OS takes about 3 GB, your operating system. If you're iPhone, then it is iOS, right? And your apps take about 50 GB of storage. Maybe if you also download lots of mobile games, then it will take even more storage, right? Your photos take 48 GB, let's say. Your videos take 100 GB. Your downloads and cache take around 20 GB. Okay? Your files take 5 GB. So the total of 226 GB, all gone, right? How will you take selfies the next year then? All your local space is gone. So no more selfies. You'll have to buy a new phone then. So what do we do? What is the solution here? So let's talk about personal clouds. Yes, bigger space. Use friend's phone. Okay. Okay. Your friend will be like, okay, please stay away from my phone. Take too many selfies. So what do personal clouds contain? Here is what iCloud backup includes. App data, Apple Watch backups, device settings, home screen and app organization, right? iMessage, text, all those things. Photos and videos on your iPhone, iPad, and iPad Touch and all those things, right? Purchase history, ringtones, visual voicemail, so on and so forth. Okay, so when you have when you like buy an Apple product, it gives you a free iCloud storage, right? So that is already a personal cloud for you, which is free. But of course, you can give them more money and tell them that you need more storage, which a service which I avail to. So yes, exactly. So your iPhone, iPad, iTouch backups only include information and settings stored on your device. They do not include information already stored in iCloud, such as contacts, calendar, bookmarks, all these things. So you're already like availing cloud services, even if you don't know about it, right? So here's what Google backup includes, like contacts, email, docs, calendars, Hangout, chat logs, all these things, right? So this is not an exhaustive list. They contain a lot of things. So you're already availing personal cloud infrastructure, whether you know this or not. Okay, if you own uh, an Apple phone or an Android phone, but not if you own a Nokia phone, then you don't have those kind of things. All right. So the most common personal clouds are Google Drive, Dropbox, Gmail. So like your emails, right? But they're also stored somewhere, not in your personal computer. So that is also cloud storage. Okay. So all these things are your personal cloud. Okay. And now let's scale it up a little bit. Now imagine a corporate scenario. All right. In a corporate scenario, what happens is that just one department that keeps security footage, right? So 2.6 GB per hour, 24 hours, 10 cameras. How much is it? That is 624 GB per day of data, right? And that is 230 terabyte of data a year. That's a lot of data, right? And this is how much data we consume or is expended in a day, right? So for example, if you are driving a connected car, that itself produces like 4 terabyte of data a day, right? And if you look at Facebook, it creates like 4 petabyte of data a day, right? And it is estimated that 463 exabyte of data will be created, every day by 2025. I mean, this storage has so many zeros, I can't even count properly. Okay, so we are getting more and more data hungry. by day, right? So, so the naive kind of question is, why not build a data storage center, right? Why not just do that? So let's build a data storage center, right? So let's just estimate the data center cost here. Okay? The cost of ownership in maintaining a private data center or co-location facility is data center cost, right? The property, structure, servers, networking gear, power, cooling system, and other network infrastructure needs, right? So your head is already hurting now, thinking that, oh, we have to pay for all those things, right? So on an average, the cost of running extensive large data center service ranges between 40 million ringgit to 100 million ringgit per year, right? The most significant expenditure is on ongoing application and supporting infrastructure maintenance. Okay. So this remainder is spent on heating, computer room air conditioners, property taxes, labor expenses. So like it's like absolutely a nightmare. I mean, I won't go into too many details, but you can understand what's going on, right? So a small data center will set you back around 400 Malaysian ringgit per square foot to construct, per square foot, okay? And the average commercial data center availability center costs between 40 million ringgit to 50 million ringgit per megawatt to construct, right? So you see, like, if you are like a small or even medium-sized company, or even somewhat larger size company, this is a significant cost to maintain your data, right? And also then there is like a time to build it. A typical data center for a single tenant use may take 12 to 24 months to be ready through planning, engineering, construction, commissioning. So you see, you're already like, no, I don't want to do this, right? And then staffing, ongoing support, scalability, like what if you build a data center and then, you ran out of space or ran out of computing power, then what are you going to do? Build one more data center, right? So that's just too much. And then there is connectivity issues that also that you have to take care of. Like having just a single supplier for connection is risky at best, right? Being disconnected even for a few hours can lead to insurmountable losses for any corporations, right? So connectivity cost from carriers and ISPs may increase when you add fiber and local loop expenses to your data center, right? So you're getting the idea. I mean, it is worse than your worst nightmares. It's just too much. Okay. So is it worth the cost and hassle? What do you think? Is it worth the cost? Yes or no? Of course, no. I mean, I know that I'm not going to build my own data center for sure, right? So once that is out of the window, let's focus on alternatives. And the big alternative is cloud computing. So before we go into the details of cloud computing, let's first understand where it is coming from, right? A little bit of history of cloud computing. So the evolution of cloud computing can be bifurcated into three basic phases, all right? The first is the idea phase. This phase incepted with the emergence of utility and grid computing and lasted till pre-internet bubble era. So there was something called grid computing where you connect various computers and try to pool their power and computing power. So that was grid computing. And then the pre-cloud phase. In this phase, the internet as a mechanism to provide application as services, right? I mean, actually, I remember that grid computing companies existed even till 2007, if I'm not wrong, because I did work for a company in around 2005 that, and the company did grid computing. It was called Grid Solve. That was the name of the company. Of course, it is dissolved now because grid computing is no longer a feasible business for small to medium size business. And the cloud phase started when the classification of IaaS, PaaS, and SaaS development got formalized. I'll tell you in a bit what is IaaS, PaaS, and SaaS, right? So it is infrastructure as a service, is IaaS. PaaS is not the political party PaaS, right? It is the PaaS. It is platform as a service. And SaaS is the software as a service, right? So this is the cloud. So in the 1960s, what happened was that one of the renowned names in the computer science, it was John McCarthy. He enabled the enterprise to use expensive mainframe and introduce the whole concept of time sharing. Okay, so you know what mainframe computers are, right? I mean, they still exist. It's just that we are not used to it because they're used for used mainly by banks and stuff like that. Okay, so and this concept of time sharing is extremely important in cloud computing because when it started, it was like there is a mainframe computer and different terminals share time with it. So, from time T1 to time T2, there is terminal A, which is doing the computing, time T2 to time T3, it is terminal B, and so on and so forth, right? So that was called time sharing. And that was the genesis of basically cloud computing. Okay. And then in 1960s as well, with the vision to interconnect the global space, JCR Licklider introduced the concept of Galactic Network, an intergalactic computer network. So already you see this whole idea of connecting computers and pooling up their resources has already started in the late 1960s itself. And then in the 1970s, by this era, it was possible to run multiple operating systems in isolated environment, right? So this computer from the 70s are the very first personal computer, okay? So previously it was the concept of time sharing, that there's one big computer and different terminals are, availing their computing power. But in the 1970s, it shifted to personal computers where there is just one machine which is self-contained and only one terminal interacts with it. So, and then in the 1980s, again, it was cluster computing came as an alternative to mainframe computing. So each machine in the cluster was connected to each other by a network with high bandwidth. High bandwidth because we needed the data to transfer fast. So that's why high bandwidth. So these were way cheaper than those mainframe systems. These were equally capable of high computations. Also, new nodes could easily be added to the cluster if it was required. Thus, the problem of the cost was solved to some extent, but the problem related to geographical restrictions still pertain. To solve this, the concept of grid computing was introduced. So you see, in many sense, if you've heard of Hadoop system, so Hadoop is a term quite related to the big data. So Hadoop is a system in which you can have like various commodity computers, and you can connect them, and it will behave like it's like a huge computer. All right, so there's lots of distributive nature of computing going on there as well. So even when you hear of modern terminologies like Hadoop or big data, know that it hasn't come out in a vacuum. There is some history behind it, and this kind of concepts have been there in the computing industry for a very, very long time. Okay, and then of course in the 1990s there was like a grid computing and stuff like that. So I won't go into too much detail. So, And then in 1997, Professor Ramnath Chillappa introduced the concept of cloud computing in Dallas. So it was in 1997 that this term was coined. Okay. And then in 1999, Salesforce started the whole concept of enterprise application through the medium of simple websites. What it means is that, you see, previously when you want to run programs on mainframe or avail their computing power, you have to go into command line and you have to be very technical in order to avail those services. But what Salesforce.com did was it gave a very user-friendly user interface to the end user. And even if you're not a very technical expert, you can still avail the computing power of the grid network, cluster networks. Okay. And then in 2003, the virtual machine monitor that allows running of multiple virtual guest operating systems on a single device paved way ahead for other huge inventions, right? So it may be that you have a server running there in the background, and then that server is like partitioned into many virtual machines, right? And each virtual machine may be serving a separate customer, right? So there may be two customers. They may be availing the resources of the same machine, but they are in virtual isolated environments. So they won't be able to know each other or be able to interact with each other. They are like virtual machines are like kind of like a personal computer, but in a shared space. Okay. Then in 2006, Amazon also started expanding in cloud services from EC2 to simple storage. Service S3, they introduced pay-as-you-go model, okay, which has become a standard practice even today. So what actually happened was that Amazon, as you know, it started as a bookstore, right? It started as a bookstore and then it expanded into, selling all kinds of stuff, right? So it was getting lots of business. So they needed to have like a dedicated team of people who sole job is to manage servers. So they have this whole infrastructure built up for managing servers. And then they thought that, our server infrastructure is so good that we can actually start offering it as a service. Okay. So that's when infrastructure as a service was born, right? So Amazon is basically giving you its infrastructure. And also what was revolutionary was the pay-as-you-go model. So you don't have to buy big servers and make like huge investments. It's not like you have to make huge price projections. It's just that you can just pay as you go, right? So if your demand increases, you can pay more and get more of the resources, whether computing or storage. And if your usage decreases, you can decrease it. So it is pay as you go model, right? So it's very easy. So with IaaS, the infrastructure as a service model, the worldwide public cloud service market was total at like 430 billion ringgit, okay, which turned out to be the fastest growing market services of that year. So Amazon just jumped into a really great opportunity because that was a time when people were producing lots and lots of data, right? And it was a good time to get into infrastructure as a service business. Okay, so so how does cloud computing work and what makes it tick? Okay. And just a precautionary note that we'll be exploring some highly technical aspects, but you don't have to worry too much about it. You don't have to understand it in its full depth. You just have to understand it enough to know how they're working. Okay? So what is computing, right? In the simplest of explanation for within our context, the use of computer is computing, okay? So even this term computing is a modern term, right? Computing doesn't mean calculating. Calculating is different from computing. Computing encompasses everything that has to do with computers, mostly software design or algorithm design, operating systems. So for example, I have a master's in mathematics and computing, not in mathematics and computer science, but mathematics and computing. So because computing is a bigger umbrella term, and computer science is just a part of it. Okay, so within our context, the use of computer is computing. Okay, so what do we have in computing? What are the major abstractions of it? One is the processor, then it's memory and storage. Okay, so processor means how fast a computer can do a calculation, right? That is the job of the processor. If you have a very strong processor, it can do calculations very fast, right? And calculation and those, that's a processor is measured in hertz, right? Hertz is or gigahertz is a unit of frequency, that how fast you can do something. That's why you'll see that the specification of the processor, it is in gigahertz, right? And then there is memory. Okay? Remember that memory and storage are used differently, whereby memory means the working memory. You can think of it like a RAM, which means that whenever you run a program, right, that program itself, it requires some memory to run. You get my point? Which is different from storage. So for example, you can have like 20 or 200 gigabyte of photos stored in a computer, right? So that is storage. But memory means, let's say you have a program which does some processing, right? So for that program to run, it requires memory. So that working memory is called memory. And the space which is just sitting there, it is called storage. So, so some, as I told you before, that some applications require high processing power, memory, and some application just require higher storage, right? So, so we have this different kinds of things, and we can, and cloud in cloud computing, you can share processor, share memory, share storage. So you can do all those things. All right. So it's just a visual representation of how things are shared, and you can share all these things differently. But the problem is, you see, the problem here is that if I'm sharing something, if I'm sharing storage with you, then there is a danger that I may be able to access your pictures, for example, in the cloud. So, or if I'm processing something, I may be able to access some data which is shared in the same processor. So in order to solve that, we have something called virtualization. It is a technology, right? So a virtual computer system is known as a virtual machine, or VM. I'm sure you must have heard of it. A tightly isolated software container, right? It is tightly isolated. The emphasis is on tightly as well as isolated, right? And which means that it's almost impossible for you to access the data of a different user who is sharing your space, right? Tightly isolated software container with an operating system and application inside. Each self-contained VM is completely independent. Putting multiple VMs on a single computer enables several operating systems and applications to run on just one physical server or host, right? So on one physical server, you can have a virtual machine running Linux, right? Or you can have a virtual machine running Windows server, right? In the same machine. So not only there is like a division of storage, you can even have like completely different operating systems running in the same server through the magic of that virtualization technology. Okay. So that's how you do it. So you see here that each user, right? Each user has his or her own chunk of processor, memory, and storage. Okay, smaller chunk of each one of them. And let's say user A, he needs more memory, so he will be allocated more memory, and all of this will be totally isolated. Okay, so just to take a bird's eye view of virtualization, right? So in looking at the market, so let's say there is a private user, right? Uses a virtualized computer for storing and managing her personal business detail. That's user one. And then there's user two, a corporate user, given access from work to manage their data warehouse. So, they are segregated by the use of hypervisor technology. So hypervisor technology is basically a virtualization technology, in short, right? And the user one or user two won't even know that, or won't even know the existence of the other user, right? They are completely separated, even though they're in the same machine. So key properties of virtual machines. So remember that virtual machines are one of the key components or key building blocks on which cloud computing is built. So it is imperative that you understand what virtual machines are. So the key properties of virtual machines. Uh, Virtualization has partition, right? So it means that it run multiple operating systems on one physical machine, right? Divide system resources between virtual machines. So that's partition. Then we have isolation. Isolation means provide fault and security isolation at the hardware level. Okay, so this isolation is at the hardware level. So even if maybe an operating system of one user crashes, it doesn't affect that, right? Preserve performance with advanced resource control, right? So even if there are two users sharing the same machine, but one user has paid for maybe more memory or more processing power, right? So this technology should be able to isolate and provide different kind of service, different level of services to different users. Right? That's isolation. And then there is encapsulation, which means that save the entire state of virtual machine to files. Move and copy virtual machines as easily as moving and copying files. And this is also very important uh, to be able to have a good virtualization, because what happens is that, let's say a user, he is using your virtual machine and he's demanding more and more resources, right? So what if he needs resources so much so that you run out of space in that particular machine, right? So to solve that problem, you can do two kinds of things, right? One kind of thing is called what we call horizontal uh, scaling, which means that you will just distribute his data into different machines. And then there is called vertical scaling, which means that what you do is you transfer all his data and everything into a different machine, which has a larger capacity. So in either case, when you have to move the data around, and you have to move not just the data, but also the state, state means you can think of it like settings, right? So you have to move those around. And in order to move those around, there should be a technology which can save all this information. In a way, it can so to say, compress all this information, capture all this information. And at the same time, after it has captured it, you should be able to decompress it, that information, in a different machine. Right? So compress, decompress. Both need to be there. So there should be a mechanism to copy the data, move the data, and operationalize the data in a different machine. Okay? And then hardware independence, which means that provisions or migrate any virtual machine to any physical server, right? So, which means that we should be able to easily transfer a virtual machine from one server to another. So all these technologies should be in place for a good virtualization system. Okay. Now, the next question is virtualization the same as cloud computing? So to answer this question, first let's explore the basic types of virtualization. Okay. So number one is the network virtualization. By completely reproducing a physical network, network virtualization allows application to run on virtual network as if they were running on a physical network, but with greater operational benefits and all the hardware independence of virtualization. So network virtualization is especially important in big companies where the computers within the same network are able to communicate with themselves, but they are restricted to communicate from computers outside the network. Right? But these networks need not be physically there, right? And the network can be virtualized. So there can be different computers, and even if strictly speaking, they're not in the same network, they can be made to behave that they are in the same network. So there's something called network virtualization. So to run on virtual network as if they were running on physical networks. Okay, so this is network virtualization. And then we have server virtualization, and server virtualization is actually more intuitive because even non-corporates like layman users, they also use server virtualization. This enables multiple operating systems to run on a single physical server as highly efficient virtual machines, right? So there are two kinds of virtualization here, network virtualization and server virtualization. So recall multiple users, it's called multi-tenancy. Okay, you know the English word tenant, right? Tenant means somebody who stays in one of your houses and pays you rent, right? And multi-tenancy means in the same house or same server, multiple tenants are there. So that's called multi-tenancy. So just remember, recall our cloud model. What happens when space or other resources run out, right? Do we create a completely new remote system? What if an existing client wants to add more resources? So this is where clustering comes in, right? So in cluster computing, a computer cluster is a set of computers that work together so that they can be viewed as a single system. Unlike grid computers, computer clusters have each node set to perform the same task controlled and scheduled by software, right? So you require software in order to operate a computer cluster. Okay. Usually computer clusters are a bunch of cheap computers connected together. And because they're connected together, their combined resources are huge at commodity prices, right? So this is how it works. So this is all cluster computing. When you go and look at a data warehouse or a data center, you'll see your racks and racks of computers. They are doing cluster computing. Okay. Then what is the relationship between virtualization, clustering, and cloud computing? How does it all work together? Cluster computing. Yeah, so cluster computing, we have something like this, just a visual model of how cluster computing works, that, different people have different, their own little world where they are, and their own virtual spaces, and they're hosted in some big computer connected together, right? So, so, so this is virtualization, and this is the cloud computing, right? So you can have different kinds of virtualization, and all of them working together. That's called cloud computing. All right. So, so you see that virtualization is a key component on which the cloud computing is built. Okay. So, what are the essential characteristics of cloud computing? So, as I said before, it is on-demand service. So, if you're in Amazon Cloud, and if you want a bigger server, you can just click a button and you will have a bigger server, bigger space immediately, right? A user must have the possibility to request a resource or service, that is virtual machines, a database, or whatever, without the intervention of the cloud provider support, right? So if I want to have more space, I don't need to, call someone and he will allocate, things for me. I should just be able to go to the service website and click a button, and I should be able to get it immediately, right? So if, for example, the user wants a virtual machine with certain characteristics, he must be able to access a web page and order it with a mouse click. Okay, this is very important. So you see, the cloud computing is not just about the infrastructure and the service. It's also about how the service is presented. You see, if you have to call, people, to set up things, then it's not really cloud computing, isn't it? And then we need to have broad network access. All the resources or services we order through the system must be accessible through the network and usable by any client. Okay, all kinds of clients. So sometimes what happens is that in a cloud computing, I mean, of course, many times when you are using your Google Cloud, you're actually awaiting this service person, but many times, especially these days, uh, the resources are not consumed by a user. These days, most of the resources are consumed by other computer programs, which are running in the background. And so, for example, many years ago, in 2009, 2010, actually, I made like a bot which would, access the timeline of Twitter and be able to break news before it actually breaks in the mainstream media. So that bot was consuming lots of bandwidth of Twitter, and during those times there were no Twitter trends or whatever. Those things did not exist then. And my bot was able to break news. For example, if there is an earthquake somewhere, people start tweeting about it. Oh, the ground is shaking or whatever. And my bot will pick the chatter up, and it will say that, there is an earthquake somewhere. And of course, after a few hours, 2 or 3 hours, or sometimes even the next day, the news will come, but my bot will break the news even before that. So basically, my bot was consuming more data than I was consuming as a personal user. But of course, long story short, Twitter shut it down immediately and kind of like banned me from Twitter for some time. And then they came up with this Twitter trends and everything. But anyway, so that was way back, like 12 years ago, right? But so this thing that other programs or other bots consume, avail cloud computing more than users is even more true now. You see? So therefore, the cloud computing should be able to service not just humans, but also all other kinds of clients. Right? There are different kinds of clients. So the cloud infrastructure should be able to serve all of them. All right. And then there is something called resource pooling, which means that all resources and services, that is storage, network, bandwidth, memory, database, uh, made available by the system are organized in pools in a multi-tenant model. Each time a user requests a resource or service, it is removed from the pool and assigned to the user. The user will not have a sense of where these resources or services are located, right? So multi-tenancy means different users, the resources are reserved for different users, okay? Even in the same resource pool. And the user himself does not know the actual physical location of where his data is located. Okay, and rapid elasticity, right? You know the meaning of the English word elastic, right? You can stretch it, right? That is elastic. So, and like for example, it is said that our brain is elastic, which means that if we try hard enough, our brain actually is able to expand, right? So that is called neuroelasticity, right? So anyway, so the elastic means anything which you can stretch easily, right? The rapid elasticity means all the resources or services made available to the user in a multi-tenant model can be assigned according to the request or automatically and released just as easily when they are no longer needed, right? So for example, if there is lots of processing going on during daytime, then you see the system should be able to provide those resources very rapidly. There shouldn't be any delay, like even of 1 minute. If uh, if a user wants resources, immediately he should be able to rapidly expand his resources in a short amount of time. So that's rapid elasticity. That should also be there. And measured service. The resources and services allocated to the user are constantly monitored to understand their use and possibly to scale them automatically on demand, right? So, for example, if you have a product, right, and lots of new users are signing up, right? So you should be able to measure, like, in per day how many new users are there, right? So that you know the growth rate, and you should be able to scale them automatically, right? So for automatically means that uh, it means that, let's say suddenly I have an application or app running. Let's say I'm the head of Twitter engineering or whatever, right? Or Facebook engineering, and suddenly there is lots of people are tweeting more than usual. So it's not like, oh, I'm looking at the graphs and I'm clicking buttons to expand my resources. No, I should have a system in place which can uh, expand the resources automatically without somebody actually clicking on buttons. All right. And there are different types of virtualization, as I said, cloud compute. So we now have a good understanding of the relationship between cloud computing and virtualization, right? So now let us now explore the various flavors and how it contributes the variety of cloud computing services. All right. So application of virtualization, right? So application virtualization. So now we're talking about different kinds of application of different kinds of virtualization. So application virtualization is a kind of virtualization which helps the user to have a remote access of an application from a server. The server stores all personal information and other characteristics of the application, but can still run on a local workstation through the internet, right? Examples of this would be a user who needs to run two different versions of the same software. Technologies that use application virtualization are hosted applications and packaged applications. So can you give me an example of application virtualization? This should be easy. Can somebody give me an example? You can either use voice or you can use a text. Application. Sorry? Paisa. Well, Actually, it's very, you are just all this social media, they are application virtualization, right? They're running applications for you in the background. I mean, there is a client that you have stored in your phone, right? But that is something what we call thin client. Thin client means it is just a skeleton of it. All the data is coming from the servers, right? So this client, this Facebook app that you have, it is just for UI, right? All the data is coming from the backend. So it's a thin client. Okay, then there is storage virtualization. Storage virtualization is an area of servers that are managed by virtual storage system. The servers aren't aware of exactly where the data is stored and instead function more like worker bees in a hive. It makes managing storage from multiple sources to be managed and utilized as a single repository storage virtualization. Okay. Uh, so some of the examples are Drive, Google Drive, and Apple Cloud, and a Dropbox, right? So what happens is that even if you're storing your file, it's not necessary that all your files are stored in the same physical location. They can be distributed, but it looks to you like they are stored in the same place, but they may not. So this is called storage virtualization, right? And then there is data virtualization. So data virtualization is a kind of virtualization in which the data is collected from various sources and managed at a single place without knowing more about the technical information like how data is collected, stored, and formatted, then arranged the data logically so that its virtual view can be accessed by its interested people and stakeholders and users through the various cloud services remotely, right? Uh, it can be used to performing various kinds of tasks, such as data integration, business integration, service-oriented architecture, data services, searching organizational data, right? Like AWS or Google Cloud and stuff like that. So one of the main differences between data virtualization and storage virtualization is that storage virtualization is usually facing the normal users, uh, like a human user, but data virtualization mostly deals with automation and stuff like that, right? So mostly the bots or the mostly other systems will be interacting with data virtualization. And it is used by enterprise companies, um, and it is much bigger than other kinds of virtualizations. And then there is server virtualization that also we are familiar with. This kind of virtualization in which masking of server resources takes place, right? So what are the server resources? Server resources is the memory, the processor, as well as the program which is running the server, right? So here the central server, uh, physical server, is divided into multiple different virtual servers by changing the identity number processors. So each system can operate its own operating system in isolated manner. So again, this is when people think of virtualization, they usually think of server virtualization. So this is the most obvious form of virtualization that we have, right? So it so each system can operate its own operating systems in isolated manner, but each subserver knows the identity of the central server, right? So it causes an increase in the performance and reduces the operating cost by deployment of main server resources into sub-server resources. It's beneficial in virtual migration. It reduces energy consumption and reduces infrastructure cost and stuff like that. So this is server virtualization. AWS, DigitalOcean, Azure Data Cloud, all are server virtualization services. Okay, so now that we understand the basics of the technology behind behind cloud computing, its various building blocks. Now let's move a little bit more towards the types of cloud computing services. Okay. So types of cloud computing services. Cloud computing services are delivered in three main models. Okay. So this is more like a business model actually, each of which offers customers different levels of support and flexibility. There is also some overlap between all three of them, so it can get a little bit confusing when trying to get your head around what they all mean. So for example, you know, mule. What is a mule? Mule is basically an animal which is born out of a male donkey and a female horse. Okay, that's a mule, right? So if you look at a mule and a donkey, they kind of look very, very similar. So it's good to know what is a mule and a donkey, and sometimes you might get confused, but it is still better to know what is what, right? Okay, so that was the analogy that came to my mind. Okay, so these services are occasionally known as a cloud computing stack, as they're often built on top of one another. So knowing what each of them is and how they work will give you a clearer sign about which service might be the best suited to your needs and requirements. Okay. So you must have heard this, as I have mentioned it before, infrastructure as a service. So what is infrastructure as a service? So also known as utility computing, right? This is the on-demand delivery of computing infrastructure. What does it mean? That means everything from operating systems and storage to networking and components and computing. It is outsourced to cloud computing company or service. Okay, all those things which are either storage or computing, all of those things are outsourced to cloud. As an individual or the company, you will buy what you need on a pay-as-you-go model. Okay. The simplest example of IaaS cloud computing is ordinary web hosting. This is where you pay a monthly fee or by megabyte or gigabyte to have a company host your file from their servers. IaaS is an extremely flexible option as it permits the user to customize the infrastructure of the computing environment. From web hosting to big data analytics, IaaS covers the whole spectrum. So IaaS is the most, how to say, a basic, not basic, I won't call it basic, but more fundamental model where you don't provide too much, you just provide the infrastructure to build it, right? So for example, if somebody wants to build a house, we just provide the land and the soil, these kind of things. And it's up to the person how he wants to build the house, right? So that's infrastructure as a service. And then there is something called SaaS. So SaaS is more specialized, okay? So software as a service, for example, even when you go to, I don't know, maybe you go to facebook.com, right? So that is actually software as a service. But it's not called software as a service because you're not paying for it, it's free, right? Usually software as a service require you to pay for it, mostly by per month. So for example, MailChimp and stuff like that, right? So actually all the software that you see on the internet, they are software as a service because you're not hosting the servers yourself, right? The companies which are offering you the SaaS, they are the one hosting it. I mean, even they are not hosting it. Of course, they're hosting AWS, but it is their responsibility to host the backend. It's not yours. You're only getting the software, and usually the software as a service is like even either monthly or yearly you have to pay. So as long as you stop paying, you stop getting the service. Okay. And as long as you're paying, then you get the service. And there are also like various tiers of SaaS, like basic plan, advanced plan, or enterprise plan. So all those different plans have different kinds of services and different prices, right? So that is software as a service. So this is when you use complete application on a third-party server or system. So users can access these applications on demand via the internet, right? Without having to download or maintain any software. So SaaS cloud tech is really popular with businesses and general users, as it is usually very easy to adopt, right? No fuss, no muss. You pay it, you get it, you stop paying it, you don't get it. Okay. So it can also be accessible from any device, and there is often a range of paid or free options to choose from. Right? So examples of SaaS applications include any web-based mail services. Like even your Gmail is basically SaaS. It's just that you don't realize it because you're not paying for it. The different services supplied by Google, such as Google Docs and Google Sheets, are also examples of SaaS. Adobe Creative Cloud Services is also another example of SaaS in action, right? With this kind of model, the user is only exposed to the interface that they choose to interact with. Okay, that's important. So the users interact with the software through an interface, which means that what they can do is limited. Right? They cannot just make some kind of SQL query to the web server. They can't do that. So the app providers, they control what services, what options you are able to avail, depending on how much you are paying. Now there is something called PaaS, platform as a service. So this form of cloud computing is often used by software developers who are looking to focus on development rather than DevOps and administration.
His vision is to be like my kind of.
Hello? There was some background noise. Somebody was trying to ask any question or something like that?
No, it's okay. I was just observing.
Oh, okay. All right. So this form of cloud computing is often used by software developers who are looking to focus on development rather than DevOps. So you can see that SaaS is focused more towards a consumer, right? But PaaS is more focused toward developers who perhaps want to build their own SaaS, right? So it is effectively an option to develop an application without having to worry about installing, configuring, and maintaining an infrastructure, right? So we looked at IaaS, and PaaS means you don't have to actually maintain that IaaS or configure that IaaS itself. So this is supplied by the server as a standardized environment, right? So PaaS cuts down the complexity of setting up and properly maintaining an infrastructure. So in a way, PaaS is similar to IaaS, but it is more, it's kind of like pre-configured, all right? And PaaS is usually used by developers, not by consumers usually, because developers who want to build their own SaaS or their own applications. And like with SaaS, you're only exposed to the interface you interact with. And by interface, we don't mean graphical interface necessarily, right? Interface means anything that you're exposed with, either through graphical means or through APIs, through application programming interface. So APIs are basically the way one computer program interacts with the other computer program, right? So it can be interfaced through other programs as well. Okay. So just give you a few examples of SaaS, PaaS, and IaaS. The SaaS, like Google Workspace, Dropbox, Salesforce, all these are SaaS. PaaS is AWS Elastic, Beanstalk, Windows Azure, Heroku, Force.com, Google App Engine. So if you are a consumer, you must have heard of Google Workspace, Dropbox, and all those things. But if you are not a programmer, most of it you might not have heard of Google App Engine or OpenShift or Heroku and stuff like that, right? Because these are usually, PaaS is usually used by other developers to build their own SaaS or whatever they want to build, any kind of app. And then IaaS is like a more fundamental thing, like DigitalOcean or Linode. They have their own server. So for example, I use all three kinds of cloud computing. I use SaaS like everybody else. I also use PaaS if I want to deploy my websites. I can use Heroku, and they used to be free, now they are paid, right? So I use PaaS, and of course I use IaaS. So in DigitalOcean or Linode, you can have like bare metal Linux servers. So I can just use that Linux server and configure it any way I want. So I use all three. Okay, so it depends on how you want to use the cloud computing environment. So types of cloud computing and how is this different from cloud computing services? So types of cloud computing environments, right? On top of different cloud systems, you can also get cloud environments, which means that not all clouds are the same, and the different types of cloud will suit different domains and how the cloud service itself is deployed. Okay, so these different types have been developed to try and suit as many different singular needs as possible. So you may also come across personal clouds and peer-to-peer clouds. Okay, so personal clouds are basically when we talk about clouds, the thing that comes to our mind is usually personal clouds. Okay? And peer-to-peer clouds are slightly different. These are smaller and more bespoke. Below we have a look at the main types of cloud environment. Let's have a look at the different types available to you. So let's have a look at public cloud first. Okay. So public cloud environments are operated by third-party providers. Okay. They provide computing resources such as servers and storage options using the internet. While this type of cloud service isn't necessarily best suited for regulated industries like the banking sector, they could suit smaller businesses. Okay. So you will notice that coming this far from the start, you must have noticed that now you start hearing terms which you've heard before, right? In a different context, right? So now when I tell you what public cloud is, it'll be easier for you to understand because you already have a background knowledge of many of the things. And in a way, some knowledge is even repeated in that sense. And one of the biggest public cloud servers is AWS, which owns and manages huge hardware and software infrastructure, which you as a user can access online. Right? So that's public cloud. So when we talk about cloud, we usually talk about public cloud, right? But that's not all, of course. There is also private cloud. So this type of cloud environment is owned and managed by one client. Right? This means that only the client's employees can have access to the cloud system. Okay? A private cloud permits you to have much greater control over your computing environment and data, and is commonly implemented in regulated industries like finance. For example, you use banks, Maybank or CIMB Bank, right? So you definitely don't want your data to be stored in AWS cloud. You know, it's a private company owned by a US entity, and you definitely don't want your banking data over there. And especially data pertaining to national security. Of course, you can't put it in AWS. You have to have private clouds. I mean, it is a necessity, right? So private clouds are usually physically located in an organization's office building, but sometimes third-party services are also employed. They're much more secure than public clouds. Okay. So in the public cloud, they trade security for ease of use, right? So it's very easy to use public cloud. But if you want to use private cloud, they're definitely much more secure, but they're also not that easy to use, or not that easy to set up. You need like special personnel who can actually set this up for you. Okay, so public cloud versus private cloud. So private cloud is single tenant implementation, okay, and and public cloud is multi-tenant implementation. And by now, I don't even have to explain to you what is the meaning of multi-tenant and singleton. You already know it by now, right? So multi-tenant means, in the same servers, different users, virtualization, etc., right? And then the private cloud is owned and operated by organization. And the public cloud is operated by the service provider. There was actually a controversy in which Amazon was involved, in which, so you see, you can read books on Kindle, right? Now the question is, who owns those books, right? When you buy a physical book, it is your book. You can do whatever with it you want, right? You can write on it and you can keep it forever. But once what happened was that due to some reasons, Amazon actually removed some of the books from the accounts of some of the users. So there was a huge uproar. There was this huge controversy that how can you remove a book? And Amazon was saying that actually the book is owned by us, but we're just renting to you, right? So you see, there is this ambiguity that who owns what in public cloud. But in private cloud, of course, you own everything. And private cloud is suited for confidential data. And, public cloud is suited for less secure data. Like, you're just taking selfies, right? So you want it to be private, but maybe even if, other people see your selfies, it's not like they can drain your bank balance or anything like that. And then private cloud, speed access according to LAN and WAN. So LAN is short for large area network and WAN is short for wide area network. So the entities which employ private cloud, they have their own LAN and WAN, right? But you see, the public cloud is dependent on on the ISP that you're using. So these are some of the basic differences. And as a user, mostly, even as a company, you'll be mostly using public cloud. It'll be very rare that you'll be using private cloud unless you're a bank or doing something very sensitive. But of course, there are hybrid clouds. So there was obviously a need for hybrid cloud because you see, if you have a look at private and public cloud, it seems like a huge polarity between them. Like they're like two extremes. Is there like a middle road somewhere? So hybrid cloud are for that middle road, right? So sometimes known as multi-clouds, hybrid clouds are basically a combination of private and public clouds. So these clouds basically allow you to move information and data between the private and public clouds. This can give your organization much greater flexibility and can optimize your infrastructure. Okay. So hybrid cloud refers to a mixed computing, storage, and services environment made up of on-premise infrastructure, private cloud services, and a public cloud such as Amazon or Microsoft with orchestration among the various platforms. So for example, maybe you are a big company, maybe you're not a bank, maybe you are some big company which still wants to have some control over your data, right? So you want to go into private cloud, but you cannot just shut everything down and then say that, okay, in 6 months we'll be up, right? So what you do is you start transitioning, right? So maybe some data you put in a private cloud and some data in public cloud, data which are not sensitive. And maybe you don't even have to transition completely to private cloud. You can maintain this hybrid cloud throughout the life cycle of the company, that less private data are in the public cloud and more private data in the private cloud, right? Because you see, as we see that both public and private cloud have their own plus and minuses, right? So we can have a hybrid strategy as well. We can have this kind of hybrid cloud. And hybrid cloud computing enables an enterprise to deploy its more sensitive workloads in an on-premise cloud and to host less critical resources on a third-party public cloud provider. Okay, this approach allows organizations to get the best of both private, and public cloud models. So in order to establish a hybrid cloud, we need to understand three things because it consists of three main components. So the first component is a public infrastructure as a service platform, such as Amazon Web Services, Microsoft Azure, or Google platform. Okay, that's number one. Number two, private computing resources, such as on-premise data center. Okay, that's number two. Number three, an adequate network connection to the hybrid cloud's private and public cloud environments. Okay, so you need to have, public infrastructure, you need to have private infrastructure, and there should be a way to communicate between the two, right? So hybrid cloud benefits are flexibility, right? The companies work with various types of data in disparate environment and adjust the infrastructure. So you can even, depending on the needs of your company, you can even balance how much data should be in, public and how much should be in private clouds. You can do all those kind of things. And then there is also cost management, like if storing everything securely is very expensive, you can move some of the data that is not very sensitive to the public cloud. So there is flexibility, there is cost management. With a private cloud, organizations own and operate the data center infrastructure, which requires significant capital expense and fixed cost, as we have seen before, right? Alternatively, public cloud resources and services are accounted as variable and operational expenses, right? So it is metered, right? The more you use, the more you pay. The less you use, the less you pay. So hybrid cloud users can choose to run workloads in whichever environment is more cost effective, right? So that is cost management. Then we have agility and scalability. So you know the meaning of agility, right? Which means somebody is agile means he's very fast, right? And scalability is basically a software term. It means that you can increase its size to however much you want. So that is scale. So agility and scalability. So hybrid cloud offers more resources options via a public cloud provider versus an organization's physical data center. So this makes it easier to provision, deploy, and scale resources to meet demand spikes, right? So suddenly if the demand spikes, then and you're only using private cloud, you won't be able to scale as fast, right? Number one, you won't be able to scale as fast. You need public cloud for that. And also, not only you won't be able to scale fast, but it will cost you lots of time and money in order to scale, right? So when demand exceeds capacity of the local data center, an organization can burst the application to the public cloud to access extra scale and capacity. Okay. And then there is resiliency and interoperability. So what is resilience? The English, the meaning of this English word resilience. Can somebody tell me? Okay, so since it is not an English class, I'll tell you. So resiliency, yes, yes, you can say that it is persistence. Resiliency usually means something that can withstand pressure, right? So it is resilient. And interoperability, that various components are able to work together. Okay, so a business can run workloads redundantly in both private and public environments. Can somebody try to tell me the meaning of this sentence? What does it mean? What is the meaning of redundancy? You see, I'm asking you the meaning of this words not because I want to make your English strong. It's because these words are very important in cloud computing and software businesses. Redundancy means, okay, so for example, if you look at your body, right, you have one heart, but you've got two kidneys. So even if one kidney fails, the other kidney can still keep you alive, right? So that is called redundancy. So you have one redundant kidney so that it is fail-safe, right? So when you have a resource more than what you require, that is called redundancy. So in an organization, there is a need to both decrease redundancy and increase redundancy. You want to decrease redundancy because let's say you have data, right? And you have like duplicate data. So it will require money to actually store all that duplicate data, right? So you would want to reduce redundancy, but at the same time, what if your data disk is corrupted, right? So you lose the data. So you want to increase the redundancy for safety, right? So that is redundancy. The business can run workloads redundantly in both private and public environments, right? So you can have the same set of data in both public and private. So components of one workload can also run in both environments and interoperate, okay? So interoperate means, let's say you have some data, you don't want to lose it, so you have it in your private cloud as well as in the public cloud. And interoperability means that, let's say the data is updated in private cloud, that the private cloud should be able to communicate with the public cloud and say that, hey, it is updated, so change your data, right? And vice versa. So that is called interoperability, okay? And compliance. Okay, so compliance is also very important because let's say you are a company and you want a contract to maybe some defense contract, right? So they would want you to have a certain level of security of the data that they're going to give you, right? So you have to comply by the conditions, right? And organizations in highly regulated industries must follow restrictions on where data can reside. And this often means that they cannot move certain workloads to the public cloud. Okay? With hybrid cloud, organizations can keep data in a private environment while operating workloads in the cloud. Or they can operate workloads in private data center and move data to and from the public cloud as needed. This allows companies to meet regulatory requirements and still benefit from the cloud's elasticity. Remember elasticity, our friend elasticity? Sorry, yeah. So what are some of the hybrid cloud use cases? Digital transformation. Digital transformation, companies often want to modernize their IT infrastructure through public cloud adoption, but legacy applications or compliance factors may preclude a business from entirely shutting down a private data center. Again, what's the meaning of the English word preclude? Preclude means to stop. Okay. Hybrid cloud enables companies with mixed data and application types to migrate part of their IT infrastructure to the cloud and retain some applications on premises. So you see, if you want to, you have like your big organizations and you need to do a digital transformation. So hybrid cloud strategy will work because you can, modernize some data and more sensitive data, you can keep it in private cloud. Okay. Disaster recovery, okay? So this ties back to the word redundancy, right? So a hybrid cloud helps organizations replicate on-premises workloads and backup data in the cloud. If there is a disruption in the data center, workloads fall over to the cloud environment and operate properly via on-demand cloud resources. So it's the same thing I've talked to you before, that this hybrid strategy really helps in disaster recovery. Development and testing is cheaper and faster to develop and test applications in public cloud because there is no need to purchase and set up on-premise physical hardware, right? So for example, I have come up, or the organization has come up with new machine learning algorithm or something, right? So they can test it in public cloud to see if it is working well or not. And once they have tuned the algorithm and whatever, then they can, do it in their private cloud. because in public cloud, it is faster and it is cheaper to test. Then data processing, right? The hybrid cloud helps organization replicate on-premise workloads and back up data in the cloud. If there is a disruption in the data center, workloads fail over to the cloud environment and operate properly via on-demand cloud services. Careful implementation is necessary to avoid hybrid cloud backup challenges, such as bandwidth consumption and management complexity. So again, here we are talking about a failover, data failover, that, and it also ties back to this point, actually, a disaster recovery. But even without disaster recovery, like some processes may fail, so you should have system so that if one process fails, the other comes up. So there is actually a technology called Kubernetes. If you want, I can tell you sometimes about it, in which it can, if one process goes down, then this system will automatically spawn another process so that your system is not down. And highly changeable workloads. So hybrid cloud is particularly valuable for dynamic or highly changeable workloads. This is also very self-evident that if your workload is changing and you have to change the load dynamically and fast, so you need to have a hybrid technology, a hybrid cloud strategy. Right? And exploring a cloud provider, right? So some organizations use a hybrid approach to evaluate a potential public cloud migration. Now, this is very important because you see, when you are changing an environment, right? You don't know how the workflow will look like, how the performance would be, whether it will really meet your business requirements or not. So you need some time to test it, right? So for example, even with medicines, right? When a new medicine is invented, and even if it has, it cures a disease, you cannot just distribute it to the public immediately. There is a long process of testing that what are the side effects, which you can know only by actually testing it. So similarly, a big organization, if it wants to adopt a cloud strategy, it needs to test first for some time, so for a period of time, to make sure that there are no side effects and it really is good for the for the business outcome. Okay, so we learned about the various concepts of cloud and various cloud strategies, and now we will focus on the public cloud services. When we say cloud service providers, we implicitly mean public cloud service providers. Okay, so we'll just quickly have a look at the pros and cons of different cloud service providers. So let's just look at the granddaddy of the cloud service providers, AWS. Okay. This AWS, a subsidiary of Amazon and founded in 2006. AWS is a leader among cloud service providers. Okay. So just I'll just give you a quick summary of this. Is that AWS cloud offering, AWS has over 175 cloud services for a broad range of use cases and industry, right? So imagine 175 different cloud services. So you have RDS, Amazon RDS for relational database, Amazon S3 for cloud storage, Amazon CloudFront for content delivery for CD service, and Amazon Glacier web storage services, and so on and so forth. Okay, and then AWS cost. AWS fees are based on pay-as-you-go model, depending on the hardware and software or networking options chosen. So a subscriber can pay for a single virtual AWS computer or a computer cluster. And also AWS budget lets you set custom cost and usage budget that alert you when your budget threshold exceeds. For example, let's say you're a small startup, right? And you have limited amount of cash, but suddenly you start signing up lots and lots of users, right? And your cost will go up very suddenly. You won't even realize it. So you can put something like a stop loss kind of thing that if the users start going more than this, then maybe don't expand it or something like that. Right. So you can set up all this kind of configurations in your AWS. So what are the strengths of AWS cloud computing? So AWS has the largest market share in IaaS and PaaS and is a leader in the majority of cloud product provided worldwide. Right, so large enterprise deploy business critical workloads to Amazon more often than to any other cloud providers. So, which is an indicator that it has a very robust infrastructure, right? So the company has a strong managed service provider network with 67 premier consulting partners worldwide. Okay? So enterprises perceive AWS as a strategic provider of cloud infrastructure. AWS delivers end-to-end solutions, starting from server to embedded operating systems in edge devices, and the comprehensive technological stack in between. Right? So just by looking at you know that AWS is, is meant for big companies actually. Medium to big companies, because it's so sophisticated, right? So what are the weaknesses of AWS? So despite proclaimed price reductions, the price for some services like the AWS computer service has not become cheaper since 2014. There are even jokes that, like some people forget about some service they are availing from the AWS and the bill goes very high. There are even some jokes and memes about it, that there was a homeless person and people are asking, how did you get homeless? He said that AWS bills. So it can get very expensive sometimes. So AWS optimizes their best cloud services, and if the customer is tied to the Amazon product, it may not be easy to switch to another service provider. This is actually, I would even suspect that it is their strategy to make switching over to another service provider difficult, right? So even their database system, it is so specific to AWS, it is very hard to migrate, right? Another challenge is using less than 20% of purchase services, which can be laborious and lengthy to re-engineer and optimize. Although appropriately priced, expenditure for AWS cloud services can go considerably high if they aren't taken care of. So, I mean, AWS is not for a very small team. It is usually for very enterprise level kind of or medium-sized businesses. And of course, it is the most mature and enterprise ready. It's very solid. I mean, its service is very, very solid. You should know that. Okay. And then let's come to Azure. I mean, Azure is, it is by Microsoft, then Microsoft Azure as it is called. Microsoft Azure holds a strong second place after AWS, right? So the company provides a broad range of enterprise-focused services, right? And again, I won't go into too much detail about Microsoft Azure as the history or whatever. I'll go into that more technical aspects like Microsoft Azure's cost. Microsoft Azure costs similar to AWS. There are some use cases where Azure is more affordable and when AWS is more economical, right? Still, Google Cloud is more affordable than both AWS and Microsoft Azure. So at present, there is a lack of standardization between cloud providers. No two cloud providers offer the same price in the same way. So for some services, Azure may offer a cheaper price, and for other services, AWS can offer a cheaper price. But across the board, the Google Cloud usually is cheaper. And what are the strengths of Microsoft Azure? The use cases of Microsoft Azure are diverse and manifold, thanks to the number of services offering and the company provides. Azure has partnership with Oracle, VMware, and SAP, further extending its capabilities, right? So Microsoft Azure has a strong managed service provider network with 32 partners in it. So you'll see that Microsoft Azure has partnered with many other companies. So, and many times if you are trying to deploy any of the products of, say, Oracle or SAP, it's quite easy to do it in Microsoft Azure with very less configuration. Okay, so that's one of the strengths. What is the weakness? The weakness is that Microsoft Azure support is quite expensive. Okay. In addition, Microsoft Azure has a lower ratio of availability zones than other cloud service providers. There's still room for resilience-centered re-engineering efforts and service availability improvements. On top of that, Azure doesn't provide any form of guaranteed capacity to its customers, and even prepaid contracts and reserved instances are not capacity guaranteed. Okay. So during the COVID-19 spike, some Microsoft Azure customers were not able to provision the cloud capacity they had already paid for. Yeah. So it seems that these are some obvious weaknesses which are not very good for enterprise software, especially software. If they go down even for an hour, there's a huge loss. So Azure is not very good for it. So again, the benefit is that Azure is particularly well suited for organizations using Microsoft services. So if you are using Microsoft services, then Microsoft Azure goes very well with that, and also services of companies with whom Microsoft has partnered. Right, so these are the benefits. Then of course we have Google Cloud. Okay, so again, Google Cloud is a big, big enterprise level kind of thing, backed by Google, of course, and the cost. The Google Cloud offers a pay-as-you-go model. A pricing calculator and custom codes can help to understand the costs based on the workloads, locations, and other variables. So Google Cloud provides $300 in free credits for 90 days, okay, which I have availed of before, to new customers that start running cloud workflows with them. Also, Google Cloud has a special program for startups, and they can get a minimum of $2,000 in initial startup credit to use. So this is pretty cool of Google, actually. Google is more startup friendly kind of company. Like they even used to have that, 20% of your time you can make whatever you want. The employees can be able to do that. I'm not sure if they still do it, but they're pretty cool with startups. So if you're a startup, they can at least provide $2,000 of credit, which you can use for free. So the strength is that Google Cloud stands out in big data, machine learning, data science capabilities. It is products like TensorFlow, MLKit, and Google datasets. Okay, it offers an end-to-end AI platform built on the latest technologies and is enabled by tools like TensorFlow and TPUs, tensor processing units. So you see, we had CPUs, central processing unit, then more powerful GPUs, and then we have TPUs that they're even more powerful than GPUs. And TPUs are used for training machine learning algorithms using big data. So they have a huge processing power. So go for Google Cloud if you're a startup, and especially if you're a machine learning startup, then Google Cloud is pretty good. So what are the weaknesses? So Google has challenges with positioning itself as an enterprise class IaaS solution. Okay, its offerings have not yet reached the level of enterprise maturity that AWS and Microsoft Azure provide, and some of them are not yet as fully packaged as the ones offered by Google Cloud rivals. Likewise, Google Cloud has a smaller pool of well-versed managed service providers than other cloud vendors. So you see, GCP is not that big on big enterprise, solid enterprise stuff. Right? If you're a startup and machine learning, go for Google. If you're a huge, business, go for AWS. Things like that. And Google Cloud benefit is that Google Cloud customers don't need to be afraid of the vendor lock-in. This is the main Google offerings are open source. So it is the exact opposite of AWS. AWS, it's like a policy to lock in, customers. Once you are inside the AWS and you have all this database or whatever, it's very, very hard, almost impossible, not impossible, but extremely hard to, migrate to some of their services. But GCP doesn't have that weakness. So it doesn't have that lock-in, right? And then, of course, there is Alibaba Alibaba Cloud cost has lower cost, around 25% than overseas cloud service providers. So that's one of the biggest strength. Is like it's a huge 25% is a huge reduction in cost, right? And even though with lower cost, it has has better CPU and memory utilization than the overseas cloud providers, making it more suitable for hosting large application workloads in the region. Okay. So the strength is that Alibaba Cloud offers a broad set of PaaS and IaaS that are comparable in availability, performance, and security. That other cloud providers provide. Okay, so that is one of the strengths. The weakness is that Alibaba has limited adoption in other parts of the world, except for South Asia. In other regions, particular services may be available only when using specific computing instances. Right. In terms of third-party software integrations and operational tools, Alibaba's international offering is limited more than Alibaba China's. Right? And investment in international market is needed for it to become a genuinely global cloud service provider. Okay, so its reach is very much limited. I think perhaps it has also to do with the fact that it is kind of China-based company, and somebody from US may not be comfortable with it concerning the data and stuff like that. And also perhaps they need to market more to other players. And you can see that Alibaba has lots of apart from price point, there are lots of other statistics which are looking very good for Alibaba. They have a 44% better average network latency than the public ISP between the US and China. So again, this word latency, you know what latency is, right? Better latency means there is no delay, there is no lag. So that is latency. And then there's Oracle Cloud. I mean, it is like in terms of enterprise cloud, I don't think it compares with AWS. AWS has huge marketing reach, and Oracle doesn't have that much. But again, Oracle Cloud has a strong partnership with Microsoft Azure, so they interoperate very well. Weakness is that it is not, in short, it is not very as well developed as AWS or even GCP. Okay. Oracle stands out among other cloud partners in its meticulous architecture and its cloud services. They're pretty competitive with the ones provided by different cloud providers. I mean, there is no doubt that Oracle has a very strong technological base, okay, but very limited. It definitely does not offer as many options as AWS. And then there is Cloudera. Okay? So Cloudera is like basically if you have anything to do with big data, then it is Cloudera. Okay, it is basically a monopoly in as far as big data goes. So Cloudera Incorporated is an American software company providing enterprise data management systems that makes significant use of Apache Hadoop. Right, as of January 31, 2021, the company had approximately 1,800 customers. Okay, so Cloudera is a platform for machine learning and analytics optimized for the cloud. So that is what it is, and it is, and let me tell you, it's very, very expensive. Okay, so these are the hourly rates. So CDH, that is Cloudera Hadoop, provides all the tools that needed to start up and operate a big data environment. So if you are a big data company, you can definitely use Cloudera. It's meant for it. Big data, machine learning with big data is all CDP. Okay. Cloudera weaknesses is limited success outside core businesses. And well, actually, you can say it is a weakness, but at the same time, it is not, because Cloudera says that it is for big data, it is for machine learning, right? So it specializes in it. But of course, you cannot use it for other things. So that is its weakness. So so these are some of the the cloud providers we talked about. Now we don't have too much time, so let's just quickly uh, have a look at the career path that you can have in cloud computing. So you can be decide to be a cloud engineer, in which cloud engineer is a broader sense responsibly manages many technical processes to the provided cloud-based system, right? Each of them comprises technologically advanced tasks correlated with either designing, maintaining, planning, monitoring of the existing business infrastructure. All right. So that is cloud engineer. Or you can be cloud architect. Cloud architect is another cloud-based career opportunity in which you will act as a person responsible preparing a cloud computing strategy, inclusive of action plans and designs for cloud systems. So, for example, the person who decides what kind of services to avail from AWS. So that is a cloud architect who architects all these different components. You should have a thorough understanding of DNS, TCP/IP protocols, and other aspects of computer networks. So side by side, you should also be having flexibility in computer programming languages like JavaScript, Python, etc. So you can proceed ahead on the path of becoming a cloud architect who can work well on his or her day-to-day expectation. So basically, a cloud architect needs to have a view of all the components of cloud computing. Okay. And then there is cloud consultant. So for example, there are consultants who consult you how to reduce your AWS bills. So that's cloud consultant. So you should have a strong IT background and you should understand the various cloud providers inside out. Then you can be a good cloud consultant. And DevOps cloud engineer are intensively involved with coordinating with various cloud developers. With the sole purpose of integrating cloud-based solutions for better performance of cloud-based projects bound to the organization's architect. Okay, so primarily this architecture revolves around technologies like Google Cloud Platforms, Microsoft Azure, so on and so forth. So this is a DevOps cloud engineer. So DevOps is, again, it's a separate huge branch of software engineering. So somebody who has a DevOps experience and has knowledge of cloud, he can be a DevOps cloud engineer. And cloud infrastructure engineer is, again, but you see here, one person can be more than one thing, right? A person can be a cloud infrastructure engineer as well as DevOps cloud engineer. So it's not that specialized that you have to learn only one thing. You can learn a couple of things. So infrastructure engineer, by definition, it works closely with hardware engineers and other developers gifted with excellent thinking, analytical, and verbal skills. So especially if you have a private cloud infrastructure, you will need a cloud infrastructure engineer. Okay, and cloud security engineer is also very important, both and in private and public, especially in private. For multi-factor authentication, he needs to have a knowledge of different authentication technologies like Kerberos, which is, again, a different thing altogether that you need to know. So that is cloud security engineer. And data engineer is basically concerned with big data and the ETL, extraction, transform, and load part of it, especially in machine learning algorithms, which deals with big data. You need data engineer, right? And then is data scientist. Data scientist, basically, you can think of a person who comes up with which algorithm to apply for this machine learning or big data task, right? So what he does, data scientist, pokes into the data and understands the data, and he decides, what kind of algorithm for machine learning or anything like that. So data scientists are expected to interpret and eloquently deliver the results of their findings by visualization techniques, right? So he needs to understand the data as well as know how to present his findings. Okay. So I think we can conclude here. So in very, very short, just to give you a very quick recap, what we learned was what is cloud computing, what are the different components of cloud computing, and what are the different kind of services that cloud computing provide, and what are the pros and cons of them, and how you can decide that what kind of services to avail. What are the different cloud computing providers? What are their strengths and weaknesses, so that you are able to better decide which one to choose for your business needs, and also what kind of careers you can choose going forward in cloud computing. So with all this knowledge, I'm sure the size of your head has increased, right? So I will stop here. Even though there is lots and lots to, I have lot more slides, but we don't have time. And this will conclude this lecture on cloud computing.